Hello, my name is Colt Correa, and I work for Intrepid Control Systems, the company that brought to you Automotive Ethernet, the Definitive Guide, now in its second edition. And this presentation is on some IP, and we're going to explain it in 5 minutes. Here we go. Some IP stands for Scalable Service-Oriented Middleware over IP, and as the name suggests, runs over Internet Protocol, either version IPv4 or IPv6. TCP or UDP can be used, but UDP is preferred because it does not have timeout or retry mechanisms that can be troublesome for real-time control in automotive applications. With UDP, the message size is limited to 1400 bytes, but if more is needed, there is a some IP transport protocol available. The motivation for some IP is to create a protocol that supports the communication of complex data structures, arrays, text-based information, and other items needed in a modern vehicle control system. Additionally, some IP is a service-based architecture where components of the vehicle can publish, subscribe, or unsubscribe to services that are needed when they are needed. This raises the question, what is a service? A service is the combination of any number of events, methods, and fields. Events, along with event groups, can be any action or change in data of the vehicle system. For example, when a door opens, a method is some action that can be evoked remotely through a remote procedure call. For example, turn on the lights. Fields are simply the data in the control system. Fields can be simple scalars, or complex structures, or arrays, or any combination thereof. Fields often have getters and setters so that remote electronic control units can get and set the value of the fields. A smartphone contact list is a good example application for this technology. Here we have a smartphone introduced into the vehicle, and the center console often has the ability to consume the phone contact list into its memory over Bluetooth. While driving the car, the user may want to see this contact list in the instrument cluster and use the steering wheel controls to advance through the contacts and make a phone call. In this example, the center console provides a service of a phone contact list to the instrument cluster. This example illustrates some of the advantages of a service-based architecture. Services can exist and come and go based on the conditions of the vehicle. In our example, maybe there's no cell phone in the car, and therefore the service of a phone contact list doesn't make sense to even exist. Phone contact list information can be some complex data: first name, last name, several phone numbers, addresses. A service-based architecture allows for this complex information in structures or arrays to be transferred across the vehicle network. Here are the basic types of communication. First, we have a method call where you have a consumer ECU making a request with parameters to a provider ECU. And the provider ECU can optionally provide a response with results, or the communication can just be fire and forget. The getter and setter on fields is similar, where a consumer ECU can request to get the value of a field or set the value of the field remotely. Event, group notification, and field notifications are essentially the same type of communication. This requires service discovery, where a consumer ECU subscribes to an event group. Part of the communication is for the provider to acknowledge that the subscription was successful. Upon successful subscription, whenever the event group trigger is set, a notification with the associated data will be sent to the consumer ECU. For service discovery, a multicast address space is necessary so that ECUs can publish and/or subscribe to services across the entire network. This is the header format for a some IP message. Keep in mind that this header starts at the UDP payload. We have a message ID which consists of a service ID and a method ID. Service is just a number assigned to a specific service, and they must be unique for an entire vehicle. The method ID is either an ID associated with a method within the service or an event or notification within the service. The client ID enables the distinction between multiple calls to the same method from multiple client ECUs, and the session ID distinguishes between multiple requests from the same client ECU. Here you can see there are different message types, including request, request no return, notification, and so forth, and a list of error return codes. Some IP defines exactly how to transfer a structure, including arrays, and so on from the memory of an ECU into a serialized format to be transferred on the wire, and then to be unpacked and put back into memory on the receiving ECU side. This is called the Transformer Specification. So there you have it, a SUM-IP overview in 5 minutes. We hope you found this video useful, and we invite you to visit our website at www.intrepidcs.com for more information on tools such as Vehicle Spy and Vehicle Spy X that support this protocol. Thank you for your time.